Okay, so yesterday we talked about inverse functions. That's going to seem to have nothing to do with what we're talking about today, but it kind of does. So let's jump in and see. So first of all, on your guys' calculators, I'd like you guys to complete this table. I'll walk you through the first one, and then I'll let you guys do the rest. So on your calculators, go ahead and what we're going to do is we're going to plug these numbers in for x. So I want to figure out what is 10 to the second power. And once I get my answer, I'm going to put it here. That's the y value. So on our calculators, go ahead and type 10. And then push this button. That's your power button, right? And then push the -2. Enter -2 and then enter. And remember, there's a difference between the negative button and the minus button. The negative button's on the bottom corner there. So y'all should be getting 0.01. Okay, good.
Or
Right.
0.01.
Oh, 0.01, okay. Go ahead and do the rest of those. I'll give you a second and I'll ask a person what they got for those. Great. So what we're going to do now is I'm going to introduce you guys to a new idea here. I doubt you've seen this before unless you took Algebra 2 before, or you just had a really interesting Algebra 1 teacher. They don't usually talk about logs. So we're talking about this new function here called a log. There's a button on our calculator for it. But what we're going to do is we're going to plug these numbers in and see what we get. So I'll walk you through the first one. I'll let you guys do the rest. But go ahead and find the button that says log. It's on the left side. And type log. And then we're going to enter this number in for x. So that would be the number right next to it. So 0.01. And then enter. And you guys should be getting -2. Bueno? All right, go ahead and do the rest. I'll ask you what you got. At this point, if you want to raise your hand and answer this question, how would you describe the relationship between this function and that log function over there? Yeah?
They're inverse.
They're inverses of each other. Nice job. You guys, we talked about this yesterday. Inverse functions are where the inputs of one are the outputs of the other, whereas the outputs of this one are the inputs of this one. They're inverses of each other. So we're learning about logs in this whole unit. But what I want you guys to understand is that in the beginning, when we first start working with logs, we're going to think about them as not logs, but as the opposite of exponent function, just because we're used to exponents. But gradually, I hope we get to a place where you stop thinking of them that way and just start treating them as their own thing. But they really are just the opposite of an exponential function. Okay? They're the inverse of that. Just like we talked about these two functions. X squared, that's a quadratic. We also talked about this function. That's a square root. Well, these are inverses of each other as well. I didn't mention it at the time, but those are inverses of each other. So let's go ahead and jump in here. So what is a logarithm? It's the inverse of an exponential function. So if you have a to the x equals y, this number here, guys, last unit, we called this the growth factor. But I also referred to it as the base, so you might want to label it that way. The logarithmic form of this exponential expression will have the same base, but that's where the base goes. It goes like a little letter or little number after the g on the bottom right of it there, right? I want you guys to notice, remember how we had this yesterday? You don't need to write this, but just reminding you from yesterday. If I have f of a equals b, then f inverse of what? B equals a. They're flopped, right? Okay, well here's my a and b. It's just x and y this time. Notice how they're switched. Here, x is what's being plugged in, y is the answer. On this one, they're switched. Y is what's being plugged in, x is the answer. Because they're inverses of each other. All right? So they have the same base. That's important to recognize. But their inputs and outputs are switched from each other because they're inverses of each other. All right? So that's what a logarithmic function is. It is the opposite of an exponential function term. But let's go ahead and get to example 1 here. It says rewrite each logarithmic equation below in exponential form. So right now, if I were to ask you guys, is this a true statement? You might be like, I don't know, that just looks like a bunch of letters and numbers. So what we're going to do is we're going to translate this into the language of exponential functions. And when you see it written that way, you're going to be like, oh, yeah, that's true. Okay, so here's my base. Okay? If I rewrite this in exponential form, it's going to look like this. What goes here is the base. So my base is 2. On this function, my input is 8, the output is 3, but we're going to swap them. So the 3 goes here and the 8 goes here. Now, is that true? Is 2 to the 3rd power equal to 8? Yeah. Then this statement over here is true also. This is just the logarithmic version of that same statement over there. Okay? Let's go ahead and take a look at the next one. Once again, we're going to have a box here. It's going to have an exponent and a box here. You don't have to use boxes. I'm just doing that for teaching purposes. But what goes in this first box here is the base. So that would be the 3. Now the next number is going to be 2. Yeah, the output. And then, and as you guys can see, 3 to the 2nd power is 9. So therefore, log base 3 of 9 is 2. And I'm not going to be too picky about how you guys say this. A lot of times people look at this, and if I ask them to read it, they'll say log 39 equals 2. I know what you mean. It's good. But here's how you're supposed to say it. Log base 3 of 9 is 2. But not a big deal. All right. So let's go ahead and do this last one here. Once again, you don't need the boxes. I just like to do it so I know what we're filling in there. Damiani, what number am I going to put here? Right? And Jedrick, what's going to go here? And then 1. Now this one's weird, but that's true. Anything to the 0 power equals 1. So, all right, so that's it. We're just rewriting them because I want you guys to, at first, as I introduce you to these things, I want you to connect them to something you already know. But eventually, I want you guys to be able to look at this and know, oh, that's true. And we'll get this. All right, so I'd like you guys to rewrite these in exponential form, and I'll ask you guys what you think. Okay? So take a minute. So there's our answers. All right. So we're going to do something similar now, but just the opposite. And I'm just doing this to really get you guys used to this whole thing here. So we're now going to write them in logarithmic form. So I'm going to do the opposite. I'm giving you the exponential form. I want you to write them as logarithms. Okay. So for number 1, the first thing you're going to do when you change into log form is you're going to write the word log. The base, this is the base right here. That guy's going to go right after the G as a little subscript. Okay. Matter of fact, why don't I stick with my usual box method here? You would fill in these 3 boxes, right? So the base goes in the first box, and these 2 numbers get flipped. So the 16 comes first, and the 4 is the answer. Okay. Let's do the next one here. Log. We're going to have a little number here. We're going to have a number here. And we're going to have a number here. So what's my base on this one? The 3, so that's going to go here. And then we have -2 and 9 left. We're going to flip those. So that's going to be 9 and -2. Now, I just realized there's an error here because 3 to the -2 is not 9. So I have a typo. So let's change that to just a +2. But that's true. I made a boo-boo. All right. Let's look at the last one here. All right. So Cal, what goes in the first little box there after the G? Yeah, nice job. 4 goes there. Owen, what am I going to put next? The 2. And then the half is last. All right? So same thing, we're just working backwards. Really just want you guys to get really used to thinking of logarithms and exponential functions together. So here's a couple for you. Any questions about those, you guys? All right. Well, let's go on to our next part. So what we're going to do now is we're going to try to figure out what these things equal. On all the other ones we've done, like on the first one here, I told you what it equals. Here, you need to figure out what it equals. Just for fun. I want to see if anybody knows. Does anybody know what this one equals? Huh? Not a bad guess. You're close, but not quite. It's 4. So you're seeing it. That's good. This one, you might have been thinking of it. Were you thinking of this one up here? Oh, okay. It's still not 6, but you're getting warm now. All right, so I'm going to show you guys how to figure this stuff out. It might be helpful to you to have out your notes that had that chart on it with all the powers. Remember we had that little chart and you had to pick out the powers? That might be helpful to have that out here today. But let's go ahead and begin here. So step 1, you guys, is going to be to say it equals x. I'll put a 1 there for step 1. Because I don't know what it equals. So let's say it equals x. All right. Step 2, we're going to change that into exponential form. So in exponential form, what would my base be? Good. And it's going to be to what power? X. We don't know what the power is, but we do know it should equal 260. Now, we've seen these before. Okay? So by rewriting this as an exponential function, we can figure out what this thing equals. Okay? Now, if you have that little chart out, it might be helpful. So I can change 216 to be 6 to the... Nice job. I don't know if you guys have memorized that or what, but yeah, it's the 3rd. And then, since I got the bases to match, what can we do with those? Drop them out, and there's my answer. Oh, I don't know why it became 4 all of a sudden. Sorry. I was thinking of a different problem, I guess. But there you go. So step 1 is going to be to make it equal x first, so we can change it into an exponential equation. And then let's use what we learned last chapter to solve it. Okay? So let's go ahead and do number 2 here. Amethyst, step 1 is what? Great. All right, I want you guys to do step 2, and I'll ask you what you got for step 2. So go ahead and do step 2 for the second problem there. What is the weird sword fighting sounds I'm hearing there? Okay, can you kill the volume there? All right, so we're working on step 2. I'll ask you what you got in just a second. You want to check your answer with a neighbor? Go ahead. Brittany, yeah, give me a second. I'll be right back. Brittany, what did you get for step 2? Okay, so now I want you guys to do step 3. So take a minute and do that. So I don't know. I'll show you. Yeah. If you guys want to know what lesson that chart was on, it's in 9.8. So if you want that chart to find out how to change power, it's in 9.8. Huh? All right. So let's take a look at number 3, or step 3. Adrian, what am I going to replace the 81 with? Three to the 4th power. And last question I'm going to throw out there is to Adrian. What's the answer? It does equal 4. Just drop the bases and those two things. So there you go. So if you guys aren't catching on, it's basically what power would you have to raise this number to get that? Okay. Let's do one more. Here we go. Miles. What's step 1? Yeah. Okay. Next, let's talk to Aaliyah. What would this be in exponential form? Great. It's kind of a trickier one, but I'll still ask. So you guys, what can I replace? This is not on your chart. Yeah. So this one's weird. What can I replace? A 4 to what power is equal to 1? It's 0. So the answer is 0. So that's a weird one. Just so you guys know, anytime there's a 1 here in a log, it'll always be 0 is the answer. Okay. All right. Just a sec. Yeah, I'll be ready. All right, guys, there's a student practice for you. So see if you guys can do those 3 problems.